a line of galaxies stretching 7 million light-years across the cosmos so perfectly aligned, so eerily uniform, has left scientists reeling. This is not just a rare cosmic structure, it may be evidence of something truly extraordinary, a cosmic bullet event that tore through the early universe, carving a trail of destruction and triggering the birth of galaxies along its wake. What we're seeing now, billions of years later, is the fossilized scar of that ancient violent sand alignment so implausible that conventional theories of galaxy formation struggle to explain it. Discovered through deep field observations using a combination of ground-based radio telescopes and space-based optical surveys, this galactic line wasn't immediately visible to the eye. It took complex mapping of radio emissions, redshift data, and star formation rates to uncover the bizarre linear structure. What stunned astronomers was not just the length of the alignment, but its precision. Dozens of galaxies seemingly strung along an invisible thread in space, like beads on a necklace that stretches across millions of light-years. This discovery emerged from a broader study aimed at understanding the cosmic web, the vast network of filaments, walls, and voids that define the large-scale structure of the universe. According to standard cosmology, matter in the universe isn't randomly distributed. Instead, it's shaped by the gravitational pull of dark matter, which forms filaments that channel gas into galaxy clusters. But even within that context, this specific formation stands out. It doesn't just follow the expected contours of a filament, it slices through the known structure like a cosmic blade, suggesting that something else, something violent may have been at work. Leading one of the key teams behind the discovery, astrophysicist Dr. Lena Moravec of the European Southern Observatory described the formation as deeply unnatural. She explained that the alignment, shape, uniformity, and velocity gradients suggest that all the galaxies along the structure may have been triggered into existence at nearly the same time, despite being separated by distances so great that light would take millions of years to travel between them. That level of synchronicity is not only rare, it's almost impossible under normal gravitational processes alone. So, what could cause such an effect? One theory is that of a cosmic bullet. According to this model, some catastrophic event, perhaps a high-energy collision involving massive dark matter structures, or even a burst from an ancient, dying black hole blasted through a region of dense intergalactic gas billions of years ago. The energy wave it released could have compressed vast areas of gas along its path, kickstarting star formation in discrete regions spaced out like rungs on a ladder. The galaxies we see today would be the glowing remnants of those trigger points, still holding the memory of the wave's passage in their spatial arrangement. The concept isn't entirely without precedent. On smaller scales, we've seen linear star formation in the wake of jets from active galactic nuclei, where shockwaves compress interstellar material in a line, producing stars like footprints in time. But applying that mechanism across millions of light-years requires a force of unimaginable scale, something beyond any stellar process we've directly observed. Support for the cosmic bullet theory comes from the fact that several galaxies along the structure show signs of simultaneous starbursts occurring billions of years ago. Starburst galaxies are those undergoing rapid star formation, often due to compression or interaction. The uniformity of these bursts' timing suggests a single event may have affected them all. Additionally, the velocities of the galaxies relative to the cosmic background radiation suggest they are moving in a way consistent with having been shoved into place long ago. Other scientists are exploring more exotic possibilities. One of the most speculative theories posits that the event responsible might not have been a physical collision, but a ripple in the structure of space-time itself, possibly from an early universe phase transition. In some models of inflation and high-energy physics, the early universe underwent several rapid changes in state, like water freezing into ice. If such a transition propagated as a shockwave, it could have seeded galaxy formation along a very specific trajectory, leaving behind a string of matter. Interestingly, this lines up with predictions from certain string theory-derived cosmologies, where topological defects in the early universe, such as cosmic